Okay, so just to reiterate, so we've been working with the powers, something squared, something cubed, something to the fourth. We're going to work with radicals, which is then the inverse of powers. So if I say 5 squared is 25, the square root of 25 is 5. So we're going to be working with the big number and our way back. Okay, what is the actual answer? Okay. To do that, we have some terminologies we have to kind of state, so when we use these words, you kind of know what they are. The first ones are roots and radical expressions. Okay. So just looking at some examples here, if I say 5 squared, what would the answer be? 5 squared is really 5 times 5, right? And so 5 times 5 equals what? 25. Okay? So what would we say then? We would say is 5 is a square root of 25. Okay? Because the exponent of 2 is squared. That's what we say. 5 squared, right? If I say 5 to the third, that's really like 5 times 5 times 5, in which we say 5 cubed, and that equals what value? You guys know? 125. In which we then say 5 is a, and because it's 5 to the third, we call a third a cube. So we say it's a cube root of 125. Okay? So when the exponent is 3, we call that a cube root. Okay? 3 sides is like a cube. 5 to the fourth, so 5 raised to the fourth power, it's like 5 times 5 times 5 times 5, and that equals 625. So 5 is a fourth root of 625. Okay? So the base number that you're using to multiply by itself multiple times is what we call the root. How many times it's being raised by that is whether it's a square, cube, fourth root. Okay, so that's how that's referred to. Does that make sense? Okay. What we do then, going the opposite way, is we want to find the answer. So if I say, well, I want to know what the square root, so here if it was a square root, I want to rate what's the square root of 25, I would use the sign, the symbol, okay, and I would put the value underneath it. Okay? This symbol right here is called the radical sign. Okay? So you put the value underneath the radical sign. Now, if you see nothing to the left up here, the radical sign just by itself, it is an assumed square root, meaning 2. Okay? So, yeah.
Is there any case where it won't tell us, where it will be something that's different?
No. If there's nothing here, if there's absolutely nothing here, it is assumed 2. Okay? So if there's nothing, these are the same. Okay? You don't put it's kind of like when you have just x, it's assumed to have an exponent of 1. We don't do x to the 1 power, we just do x. So when we see x, we know the exponent is 1. Same thing with this, okay? If it's a cube root, though, and I want to say, well, I have 125, if I don't see anything up in the upper left-hand corner, then I think it's a square root. But I want it to be the cube root, so I have to tell somebody that it's the cube root. So then I'll put the root that I want up here in the upper left-hand corner. Okay? It's not out and to the left, it's in the upper left-hand corner. So that's telling me it's the cube root. That means I want to find the number that I had to multiply 3 times to make that number. Okay, so cube root means I had to multiply 3 times to get to that number. Okay, on the fourth root, okay, so fourth root is where I had an exponent of 4. So to say I need to know the number I multiplied 4 times, so I would do my value here, okay, I would put a little 4 up there. And this would say, what number do I multiply by 4 times to actually get to have gotten 625? Okay, so this kind of explains how I went from the 5 to the 4th okay, and got a value, and now I want to know what the fourth root of it is. So this tells me I'm looking for the root. I'm looking for the value that I had to multiply 4 times to actually get there. Okay? So all these symbols have words to it. So down here you'll see those words. The number that's in the upper left-hand corner, we call that the index. Okay? So this 4, this 3, this implied 2, that's the index. Okay? What's underneath the sign is called the radicand, and then the symbol itself, right here, again, is called the radical sign. Okay? And this whole expression here is what we call a radical expression. Okay? And so our goal today is to be able to take what's underneath the symbol and to break it down to simplify it. And what you did today with the card game is you actually mimicked that process. Okay? So, we'll get into that in a sec. So, if I ask you, what is the square root of 25? So, we're looking for a number that multiplied by itself twice gets the value of 25. So, what is the square root of 25? Does anyone know? It's 5, right? So, I have the square root of 25 is, can be 5, because 5 times 5 will get me 25, right? What other number might get me 25? Yeah, -5 and -5. So when you have a square root, you can have a plus or minus as your answer. So my answer for the square root of 25 could be plus or minus 5. That is a true statement. Okay? So -5 times -5 can give me 25. 5 times 5 can give me 25. Right? Okay. So the word principal root is something that we want to reference when it comes to this answer. If I have a plus or minus 5 and someone says, what's the principal root? The principal root is going to be the positive answer. So the principal root on this answer would just be 5. Okay? So it's a positive root. So if I have plus or minus could be my answer. 5 is my principal root. Again, this is just more definitions. Okay? Does that make sense? Okay. All right. So let's look at some numbers here. So now we're going to focus on the cube roots. Okay? So if I want to know the cube root, I'm looking for the cubed root, so a number 3 times what is going to make this number. So if you're noticing the number that's up in the upper left-hand corner, the index, that is telling me how many times that number needs to be multiplied to give me that answer. Okay? So when we did the deck of cards and we had 3 9s, and I said make it a 3 of a kind, you took those 3 9s and you put them together, right? Those 9 times 9 times 9. That made a cubed root. So this tells you how many times a number needs to be multiplied by itself to get an answer. So do you guys know of a number that multiplied by itself 3 times would give me a negative 1,000? Negative 10? Okay? Because negative 10 times negative 10 times negative 10 gives me a negative 1,000. Okay? So you actually can have a negative number, okay, underneath this radical sign. But the only way that you can have a negative number underneath the radical sign is if your root is odd. Because what would be a negative 10 times a negative 10 be? It'd be a positive 100, right? So you can have a negative underneath the radical sign, except for your root must be odd. Yeah, it'd be not, yeah, no solution, no real number. Okay? So then therefore the answer is negative 10 for the cube root. Alright, let's look at the cube root for 0.008. So I'm actually looking for a value of, I'm looking for a value that would make 008. So what number do you think I have to multiply by 3 times to get 8? 2 of some sort, right? So what about those decimals? How does that work? Do you guys know? So I'm going to multiply it 3 times. So if I do a 0.002, 0.002 times 0.002 is actually going to give me 0.00004, right? So therefore, I have less. How many zeros do I need? How many do I need to move over? 3 times. I'm doing 3 times. It has to be 0.2. 0.2. Okay. So 0.2 is going to, 3 times 0.2 times 0.2 is going to get me the 0.008. Right? Does that make sense? I want a number that's multiplied by itself 4 times to get negative 81. Is there any number you can think of that multiplied by itself 4 times gives me negative 81? No, it's impossible. You cannot have any even number that's negative to make a negative number. It doesn't work, because 2 negatives equals a positive. Alright, so no solution. Not possible. Okay? How about square root of 25? So again, it's implied 2, so what number do I need to multiply by myself 2 times to get 25? Plus or minus 5, so therefore the principal root is 5. The principal root is going to be 5 because it's the positive answer when there's 2. Okay? Alright, now I'm looking for the cube root of 64. So I need a number that's multiplied by itself 3 times to get 64. 4. Okay, because 4 times 4 times 4 equals 64. So therefore it is an odd. It's a positive, so therefore it must be a positive. Okay? So here's a special note that even roots, so meaning like 2, 4, 6, etc., must have positive radicands. Okay? Must have positive radicands. So the only way you can have a negative is if you have an odd index. Okay? Bless you. Alright, so this is kind of just a setup, and now we're going to actually practice it. Okay? So let's flip. Alright, so the whole point of what we want to be doing is we want to be taking what's underneath the radical sign and eliminating, is finding the answer to that as best we possibly can without punching it into a calculator and getting a decimal. Okay? We want to simplify the number we have underneath there. Ideally, if we can find the perfect squares or the perfect cubes or whatever, that actually makes it way easier. And that's when our chart's going to come into play. Remember that chart we just used for our last test? That will be big time this time. Okay? So, what are some perfect squares? 4? 9, 16, 25, 36, 49. Oh, he's got it. 16, 25, 36, 49, etc. And what makes those perfect squares is that these are like 2 times 2, that's 3 times 3, that's 4 times 4, 5 times 5. Meaning that the number times by itself gives us that value. There are no decimals, there are no remainders, etc. Okay, those are perfect squares. Okay? So our goal when we're working with a radical sign is to find the perfect square, cube, fourth, depending on what you're looking at. If I see a radical sign like this, I'm looking for the perfect square. If I see a radical sign with a cubed, the 3, I want to find a perfect cubed. Okay? Or if I don't find a perfect square, I'm looking for 2 of a kind. Okay? If I don't find a perfect cube, I'm looking for a 3 of a kind. Okay? If I have a radical sign with a 4, I'm looking for a perfect fourth. Or I'm looking for 4 of a kind. Okay? The number, your index, is telling you what groups you're looking for when we do this. Okay? So if I'm looking at this right here, I have square root of 25. What am I looking for? Perfect what? Perfect square or 2 of a kind. Okay, that's what I'm looking for. Perfect square or 2 of a kind. Alright? So how do I find this? So what we do is we break each number down, and you can do it a bunch of different ways. I'm going to show you the way I like the best, and you can decide that works for you. Is I like to take the number and create its factors, and you break down the number to the all the common factors, all the factors you can of that number, till you can't break them down anymore. So what are some factors of 24 that you guys know of? What's that? 4 and 6? Okay, 4 and 6. Okay, so now that I've started here, okay, so if I start here, then I ask myself, can I factor either of these numbers anymore? I can do 2 and 2 here, and I can do 2 and 3 here. Okay? At that point, can I break it down anymore?
No.
I can't. Okay. So now I'm looking for 2 of a kind. Right? There's 2s right here. There's a 2 of a kind right here, right? Okay? What did I do in the card game when I found a pair of 2s? I brought it out to the left, and I wrote it to the left-hand side. I have 1 pair of 2s. Alright? So really this is like saying the square root of 4 and the square root of 6 because it's underneath the square root. What's the square root of 4? 2. So I'm going to take that value, I'm going to move it to the left. Okay? So I'm going to look for any pairs. Because my index is 2, I'm looking for pairs of 2. Any pair of 2 I have, I remove it to the left and write it as a book of just that one number. Right? I'm not writing 2 and 2, I'm just writing one set of 2. Okay? What's ever left in the inside, what did we do what was left in the inside? We multiplied them. So this is really 2 times 3, which is what? 6. Okay? So what I'm looking for is taking the value underneath my radical sign, and I want to break it down to as much as I can with my factors. I look for the amount of pairs I need. So if it's a 3, I'm going to look for 3 of that number. If it's 4, I'm going to look for 4 of that number. And I'm going to then remove them to the left, write that number once, and then anything that's left underneath the radical sign remains and gets multiplied. If I remove multiple numbers to the left, what did I do with those numbers? I multiplied them, right? Okay? Okay, that was a great question. So let's say I picked a different way of factoring. I said 8 and 3. I'll do... right, but here's any factors that you break it down to, you'll eventually get to the same on the bottom, right? So I'll do 3 and 8. What can I factor any of those anymore? 4. I can do 4 and 2, and then 2 and 2, and then here we go. We have a pair of 2s, and then we're left with the 6 underneath. They may not be. I mean, you'll eventually always get to something that you can pull out, unless it's a prime number. The only time you wouldn't be able to do it is if there's a prime number. Okay? What'd you say? 6 and 16? Okay, let's do 6 and 16. Okay, so 6 and 16. So it's like saying the square root of 6 and the square root of 16. If you see right away, like I see the square root of 16, do you guys know what the square root of 16 is? It's 4. You can just automatically throw it to the left. Okay? Because I know the square root of 16 is 4. Okay? But if you don't see that, work through the process. Yeah?
So if you see that, then the end thing would be 16 over on the left, and then...
No, it will be 4, because the square root of 16 is 4.
Oh.
So it would be 4 square roots of 6. So if you see this right away, this becomes 4, so that goes automatically to the left, so that'd be 4. And then I'm left with square root of 6 underneath because there's nothing else I can do with that, right? Because that's just going to be a 3 and a 2. And I can't, it's not a pair. But this is going to be 4 and 4, right? So what do? I take this value, which is 4, throw it to the left, and then multiply what's underneath it. Okay? So if you don't see it, just break it down to the 4 and the 4, and then do the 3 and the 2, and then do the process. I need a pair of 2s because it's an implied 2 here. So I need pairs of 2, so I take that pair of 4s, I throw it to the left as 1, and then underneath the radical sign is everything else multiplied. Question?
If you didn't see the factor of like...
Oh, 2 and 2, and 2 and 2. So if you go all the way down the factor tree, you're going to be left like this. Perfectly fine. So now I ask myself, okay, I need pairs, and I need to throw them to my left, right? So I have a pair of 2 here, and I have a pair of 2s here, right? So I'm going to put those to my left. I'll do 2, I'll do 2, that cancels, and then I'll have my 3 and 2 here, so I have the square root of 6. So my 2's come out to my left, right? What did I do with the left side? I want to multiply them, so 2 times 2 is 4, and then square root of 6. Okay, so either way, if you recognize a square root right away to throw it out, you can do that. If not, you work your way down to the very bottom. You find your pairs based on how many the index is telling you. You pull them out to the left. Okay, you only write them once. Each pair is just one number. You multiply them on the left, and then anything left underneath the radical sign, you multiply. Okay? Try 48 for me. 48 and 75. Give it a shot on your own. So the square root of 48, you guys might have said what? What did you say?
I
2 and 3 4.
2, you did 6 and 8, 6,
Yeah.
2, 6 and 8? Okay, I'll do 6 and 8, 6 and 8. Alright, so then 6 can be broken down into 3 and 2. 8 is 4 and 4, or 4 and 2. 4 is 2 and 2. Okay? So now I'm going to find, I'm looking for an index of 2, so I'm looking for pairs of 2. So, or 2 numbers to pull out. I have a set of 2 here, and I have a set of 2 here. So that's 2 times 2 I'm pulling to my left. And then underneath my radical sign, I'm left over with just 3. So this becomes 4 square roots of 3. Okay? 75 is going to be 25 and 5, or 3. And then, if you notice that it's the square root of 25 is 5, so I know it's going to be a 5, but if you don't see that, you can do 5 and 5. Okay, so I have 5, 5, and 3. I'm looking for a 2, because that's my implied 2, so these get pulled out to the left, which is 5. I'm left with the square root of 3 underneath. Okay? Alright, so now we get moving on where we have variables. Okay, this is all numbers. Numbers seems great. The variables are going to be the same thing. However, I think variables are a little bit easier to pull out. Okay? Because you don't have to really break them down. You can just look at the exponents. Okay? So the numbers are going to be exactly the same. So if I'm doing this, I'm going to look at my number and I'm still going to do my breaking down. So I have 2 and 2, right? Well, then I have all these x's, right? So I'd have like x if I did this like this. And this could be a lot of work. Right? So if I would look, I'm looking for pairs of 2, okay? So I say, oh, here's a pair of 2 I'm bringing out, so I'd bring out a 2. I have a pair of x's here, a pair of x's here, and a pair of x's here. So I have 2 times x times x times x. I don't have anything else underneath here. This is just 0. Everything branches out, so that the radical sign will just go away. So if you actually use everything underneath the radical sign, the radical sign goes away. Okay? So if I multiply all those, I get 2x cubed. Okay? Does everyone see how I broke it all down and pulled them out? So I did 4, I broke 4 down to 2 and 2.
Yes.
And then I did my x to the 6, and I just did all the x's. There's 6 of them here. My index is 2, which tells me I can pull 1 x out for every 2 I have, right? So I pull out 1 x, I pull out another x, and I pull out another x. So I have 3 x's I pulled out. I multiply them all together, and I have 2x cubed. Okay? Well, that is going to be a lot of work if I have a lot of variables and a lot of exponents, right? So how you want to work with exponents is for exponents, take the variable's exponent underneath the radical sign and divide it by the index. Okay? So for variables, okay, you want to divide the exponent by the index. Okay? The whole number answer is what you pull out. Your remainder is what's underneath the radical sign. Okay? So here's an example. If I have the square root of x to the 9th, okay, what is my index? What is my index? No, it's not 1. Index is 2. Remember, it's an implied 2 if there's nothing there, right? Yeah.
Wait, so it's, you divide the exponent by the index, and the whole number answer is what you pulled out, and your remainder is what?
Your remainder stays underneath the radical sign, okay? So, if I do this, I will do 9 divided by 2. What's 9 divided by 2? 4. Okay, and I have a remainder of 1, right? So therefore, I'm going to pull out 4 x's. So I'm going to have x to the 4th, and then underneath my radical sign, I would have x to the 1. Okay, so I take my exponent, I divide it by my index. If you don't see anything, remember your index is implied too. So I take 9, and I divide it by my index. I'm going to get 4. I have a remainder of 1. So therefore, I have an x with 1 underneath the radical sign, and I have an x to the 4th outside the radical sign. Okay?
Where did you get the 8 from?
I did 4 times 2 is 8.
So that'll be your answer.
So you go,
So I take 9 and divide it by 2. So this is my exponent.
okay,
This is my index. I divide it. 2 goes into 9 4 times. I take 4 times 2 to get 8. I subtract the 2, and then I get my remainder. Okay? So therefore, this is how many gets pulled out, and this is how many stays under. And it's not 4x, it's x to the 4th, because we're working with exponents, right? Okay? So let's try something else. Let's say it's the square, now let's do the cube root of x to the 11th. Okay, so the cube root, x to the 11th, is going to be 11 divided by, oops, sorry, I don't need that, divided by 3. Okay, that's my exponent divided by my index. So what's, 3 goes into 11 how many times? 3. So 3 times 3 is 9. I have a remainder of 2. Right? So therefore, I'm going to have x to the cubed pulled out, and then underneath my radical sign, I'm going to have x squared. Okay, so this is going to go there, and this is going to go there. Okay? So you use your index, divide your exponent by your index. That tells you how many gets pulled out, and that tells you how many is stayed in there. I didn't. I did right here. 11 divided by 3. I have 3 here, so 3 goes into 11 3 times. 3 times 3 is 9. I subtract the 2. I have a remainder of 2. So the whole number goes on the outside, and the remainder goes on the inside. Have groups of 3. Before I pull one out, I have one group here, I have one group here, I have one group here. So I have 3 groups I can pull out, right? This becomes my x cubed. I have 2 left over, so that remains underneath here. So that the division is just a really easy way to do that. Okay? Alright, so let's look at some of these right here. So I have the cube root of a cubed b6. So I'm going to take the 3 and divide it by 3. How many a's? What 3 divided by 3 is what? 1, right? So I can bring 1a out. I have 6 divided by 3. What's my whole number? 2. So I can bring b squared out. Since the remainder is 0, nothing remains underneath the radical sign. Okay? Alright, let's look at x to the 4th, y to the 8th, 4th root. 4 divided by 4 is what? 1. So I have 1x I can bring out. 8 divided by 4 is how much? 2. So I have 2 y's I can bring out. Okay? Alright, let's look at this one here. What's my index on this one? 2. Alright, so now I'm going to take my 4 and break it down into 2 and 2. And then I look at my x's. I have x squared divided by 2. How many x's can I bring out? Okay, I can bring out 1x. I have y to the 4th divided by 2. How many y's can I bring out? 2. Alright, and then I'm looking for pairs, which I have a pair of 2's here. So how many 2's can I bring out? 1. Do I have anything else underneath the radical sign? No, so that would be that answer. Okay. Negative 27. Okay, what would be my values for negative 27? I could do, let's do 9 and 3, and then 3 and 3. They all have to be negative, because that's going to give me my negative 27, right? Alright, so then I'm looking for cubed root, so I'm looking for groups of 3. So I have 3 negative 3's, right? So I can bring that out. So this is all 1. Because the index is 3, now I'm looking for 3's. So you use the index to see how many pairs to bring out. How many of that I can bring out. So it says 3, I need 3 of that like numbers before I can pull it out. Now I take 6 and I divide it by 3. So what's my answer on that one? 6 divided by 3 is 2. So how many c's can I bring out? 2. There's no remainder, so then therefore everything else cancels.
So you have, let's say to the 4th, the index is 4, and you pull out 3, like 4 4's. But what happens if you don't have four fours?
If you don't have the total in there, then it's just that number remains.
Okay.
Yeah, if you can't find a total, like let's say this was to the fourth, okay, I couldn't bring any of that number out. It would just stay negative 27.
And if it was like, if it was to the fourth, but you had like 4 negative 3, does that count, or you have to have 4s?
No, any number.
It could be any number.
Yeah, it's any number that's like 4 of a kind, 3 of a kind. The index tells you how many of a kind you need to pull it out. Doesn't matter what number it actually is.
Okay, but it just has to be like that. First.
Yeah.
Okay.
Uh-huh.
Could you move over the 4x squared one or,
This one here?
yeah.
Okay. So I take my 4 and I break it down to 2 and 2, right? My index is 2, so I'm looking for pairs of 2 of a kind, right? I have to have 2 of a kind to pull a number out. I have 2 2s, so that becomes a 2. Then I look for x squared. I take my exponent divided by my index, so it's going to be 2 divided by 2, which is just 1. So I pull out a 1x, or x to the 1. I have y to the 4th. I take 4 divided by 2, and so that's 2. So I can bring out 2y, so that's y squared. And that cancels everything. I don't have anything else underneath the radical sign.
Why do you not have any radicals for these ones, like for the instead?
Because they have perfect, there's nothing left over underneath the radical sign. Like the numbers just work out to be good. It's an even, because 2 goes into 4, you have 2 2s. I mean, if this was 3, it would be a whole different story. It just happens to be that case. Okay? Alright, if you guys flip over to the back of this worksheet, okay, we have a whole bunch of examples here. The one thing I just want to show you on 7, that's a little bit different, is what do you notice about 7?
Has an 8 underneath the number.
Yeah, it actually has a number on the outside. So what happens is whatever you find is your answer for the radical sign, you're going to multiply anything on the left with that value. So let's walk through number 7 together. So let's break down 24. So what's my index on this? 2. So I'm looking for 2 of a kind, right? I'm looking for 2 numbers that I can pull out. So let's do 24. We'll do, what, 12 and 2? And then 12 we'll do 6 and 2, and then 6 we'll do 3 and 2. So I want to pull out groups of 2, or 2 of a kind. So I have 1 2 of a kind here. So I'm going to pull that 2 out. So I pull it to the left, and I'm left with 3 and 2 underneath, so that's going to be the square root of 6. But I have this 8 here. So all I do is just multiply whatever I bring out with that 8. Okay? So I'm just going to multiply this 8 times that 2 now. Okay? So that becomes 16 square roots of 6. So anything that's to the left, I'll just multiply anything else I pull out to it. So don't ignore it or forget it. See that it's there. Okay? Does that make sense on that? So you do the process the same, and then whatever's on the left, multiply with what's already there. Okay? Alright, so you guys actually have, so you want to be looking at, these are all square roots on this page, so you're really just, your index is 2. On your homework, which is on the back, you want to be looking at your index to know what you're pulling out. So if I have a cube root, I'm going to look for 3 of a kind. If I have a 4th root, I'm looking for 4 of a kind. Okay?
Was this a negative, positive? What is your word?
Negatives underneath here, you mean?
Like, if, for instance, I'm going to tell you I'm saying a positive radical sign of x.
On which one? Oh, the front page?
No.
Oh, in the homework?